You said go.
Go. All right. So 11.1 is called Radical Expressions and Exponential Exponents. Okay, so what we're going to be working with is simplifying radicals and simplifying rational exponents. So, first of all, what are the meaning of those words? Okay, if you see the word radical in math, what does that mean? What's a radical? A square root is an example. Square root, what else?
Exponent.
No. Anything with the root. Exactly. Okay, so we're talking cube roots, fourth roots, fifth roots, sixth roots, seventh roots, eighth roots, nth roots. Roots. So why do they not call a root a radical? I don't know. They're the same thing. I don't know. Radical sounds cooler, I guess. Okay. What about a rational exponent? What does that mean? What does rational mean? What? Kind of. It is real. I agree with that.
Zero.
Not necessarily, although included in those values. No, it's not a variable. Rational numbers are numbers you write as fractions. Okay, so we're talking about fractions that are going to be in the exponents. Okay, so the first thing that I'm going to show to you guys is how to go from radical form to exponential form. Okay, and I'm going to pull this off over here and just go straight to the nitty-gritty. Okay, so we're going to start with radical. Whoops, let's not use a highlighter. That's not going to be good. Radical form. Okay, so let's say we have an nth root of some number, calling a my sum number, to the mth power. Okay, so this is radical form. You can see the root. We can convert that into exponential form. Anybody want to take a stab at what the exponential form would be?
A to the m over n.
M over n. Very good. Okay, so simply, whatever the root is goes into the denominator, and whatever the exponent piece is goes into the numerator.
Oh, I remember this.
Yeah, I know.
You knew this already. Perfect.
Yeah.
So, for example, if we have a square root of 3, which form is this one in?
Radical.
Radical. What is the exponential form of this?
3 to the 1/2.
Good. 3 to the 1/2. Everybody's okay with that? Because both of the numbers are involved are invisible, right? This is a square root to the first power. So the root goes on the bottom and the exponent goes on the top. Shall I keep going? Only if you can. And I'll explain what that means. Yeah, that was a very perplexed look. All right, so I'm going to scissor this, pull it off to the side. All right, so here is what you will see. Okay, a few examples. Okay, so all we're going to do is we're going to convert it to whatever the other form is and then simplify as far as we possibly can, if we even can. Okay, so for A, what form am I given? The exponential. Okay, so the first thing I'm going to do is I'm going to convert it to the other form. So what is the radical form of this? The cube root of Negative 125 to the fourth. And notice that I left 125, the negative 125 in parentheses. That is not completely necessary. No, I lied. That's totally necessary.
Wouldn't it be
Yeah. Well, yeah.
It would be the opposite.
It would be negative. Right. So I need the parentheses for sure. Okay, now that we know that, how do I break this down? Okay, so there's two ways to go with this. Okay, I can do this to the power and figure out what 125 to the fourth power is, and then go to the third root of that. So anybody know what negative 125 to the fourth power happens to be? Calculator might know. So let's try to not use the calculator. So let's make things smaller because our brains work that way. And then go bigger. So what is the cube root of negative 125? Negative 5. So we can say this is negative 5 to the fourth power. Anybody know what negative 5 to the fourth power is? What'd you say?
550.
So it's whatever 125 times 5 is.
625.
625. Nice. Good math. Okay, so if we can reduce it into a whole number, then we always want to do that. Okay, let's try B. Okay, B says x to the 11/8. What form is it in currently? Exponential. So we're going to convert it to radical. What's my radical form of that? 8th root of x to the 11th. Holy cow. Okay. Now, can I simplify that?
No.
Okay, so remember what we just did with breaking radicals on the warm-up? Okay, so I look at my 8 and I say, how many times does 8 go into 11? 1 with how many left over? So we're going to say 1 comes out and 3 stay in.
Oh, I hate that.
What if it leaves it twice?
What's that?
You have to leave the
Yeah, because it's still an 8th root. If it went in twice,
Yeah.
then you would say x squared.
Okay, not like 2x.
Right. Good question. Okay, ready for C? Okay, so C says the 5th root of 6 to the 4th power. Okay, now there's kind of two ways we can go about doing this. We can figure out what 6 to the 4th power is, and then do the 5th root of that. Anybody know what 6 to the 4th power is off the top of their head? I don't know either.
It's 1,296.
Oh. And
That wasn't
does there happen to be a 5th root of that number?
What?
5th root? It's not going to be a perfect 5th root.
Mm.
So, if we're in radical form, we're going to convert it to exponential. So what's the exponential form of this? 6 to the what? To the 4/5. Okay, and all I would do at this point is, can I reduce the exponent? No. You can leave it that way. Okay, last one. D. I've got the 4th root of x cubed. So we're in radical form. What's the exponential form? X to the what? 3/4. Can I reduce 3/4?
Nope.
No. Done and done. Not too bad? Okay, let's see. I think there's a couple other mores. That's what happens that's how you talk when you yeah, return after not using your brain for a while. All right, here's a few more. Okay, so we're basically doing the exact same thing. We're going to convert to the other form and then simplify. Okay, now A is in which form right now? Exponential. So I'm going to convert it to radical. So what's the radical form?
Was that a 5?
It is a 5. Yep. Do you want me to try to zoom in a little?
Roots.
5 roots?
The fifth
Root, sorry.
Of our fraction, right?
Yeah, square.
Squared, and we want that in parentheses. Okay, so what do I do? Think you can do this without a calculator? Okay, so let's start by using the 5th root. What's that? Kind of. Well, you still gotta think 5th root. Okay, so we're gonna try 5th rooting this fraction. So all we're gonna do is take the 5th root of the top and the 5th root of the bottom. So anybody know what the 5th root of negative 32 is? It is 2. Anybody know how to type that in the calculator, by the way? You do need to know how to type this. Yeah, so practice this. Make sure you can type this in. Oops, I already did that. So you start by typing the 5, whatever root you're working with, and then you hit math, and you're going to use that 5th option. Okay, so negative 32. So we're working with negative 2. Okay, so what is the 5th root of 243? Anybody want to make an educated guess? 3. Can you believe that? Look at the difference in numbers. 3. Okay, so now this is squared. So now how do I square a fraction? Yeah, you square the top, you square the bottom. So what's a negative 2 squared? 4. And 3 squared? That was really hard for me to say. I really wanted to say the answer. 3 squared is 9. Did you guys say that already? Sorry. Good there? I will tell you that working with fractions on this is so much easier than working with decimals.
Yeah, I was just looking at C. I was like,
Yeah, that's a perfect example. Yep, that's what I'm going to do. All right, what about B? Let's work with B real quick. So what form are we in? Exponential. What will be my radical form of this? Try to say this one correctly. The c-th root of 3y, which requires parentheses, to the b-th. Fair enough. That's as far as you can go on that. The c-th root of 3y to the b-th. All right. Now, how would I go about working with c? That's totally where I'm going. Okay, the first thing I'm going to do is I'm going to say I'm starting with radical, so let's go straight to exponential. So what's the exponential form of this? So it'd be 0.5 to the 9/3, right? So can I go now and say that 0.5 is equivalent to 1/2? And I'm going to put this in parentheses because now I'm working with a fraction. And 9/3 reduces to 3. Okay, so now I have a fraction with an exponent. So now I'm just going to do 1 to the 3rd power and 2 to the 3rd power. So what's 1 to the 3rd power?
1, not 3.
It's okay. It's like a Monday morning. What about 2 to the 3rd power? 8. See how we can do that without a calculator? So much easier to work with fractions. Okay, what about D? Now this is kind of an interesting one because they throw out this alternative scenario that you haven't quite seen. So what form is this? It is technically radical form. Because you got a radical. So, just so you know, this is the same as the uth power of st to the vth. So, if I'm in radical power, what's the exponential form of this? St to the v over u. Yeah. What do you mean by that? Oh, yeah. These two statements are equivalent. Because it's kind of like, it's kind of equivalent to like multiplication versus division. In the sense that if I have, what's an example? Let's say I have 4 times 3 divided by 2. It doesn't matter which order I do that in. So I can change the parentheses. Same thing with radical and exponential. Technically, they're equivalent, like as far as your PEMDAS goes. Does that kind of make sense? So what do you guys think? Should we do an example of a story problem? The story problems are really straightforward. Shall we do an example? Or would you like to tackle it when you see one? I have full faith that you guys can do this without. In fact, these ones are a little bit more complicated than the one that's on your homework. So I think we're going to call that quits, and I'm going to give you guys your homework.